3.2, we will talk about phase change process of pure substances. Okay. First, we need to introduce some terminologies related to the phase change processes because we have a bunch of terms that you need to know. Okay. In the later section, we would frequently use these terminologies. So make sure you memorize what the terms means. Okay. Here, we will use heating the water at a 1 atmospheric pressure and 20 degrees C as an example. Okay, note that for all of the pure substances, they will have a similar behavior. Okay, first of all, suppose the water is not heated and it is put in a room with 1 atmospheric pressure and 20 degrees C. And let's assume that this cup of water have a thermal equilibrium with this room. Okay, so it is also in a 20 degrees C. Okay, and here the water would exist in the liquid phase and it is not about to vaporize. So it is called a compressed liquid or subcooled liquid. Okay, and well, I prefer the name subcooled liquid. Okay, because for compressed liquid it is more about pressure. But you will see why we will also have this name when I talk about section 3.4. Okay, and after we have heat the water at a constant pressure to 100 degrees C, then you will see that the water would start to vaporize. But note that here the temperature of the water just touch 100 degrees C. Okay, so it is a liquid that is about to vaporize, and we would give a name, saturated liquid. Saturated liquid. This saturated means you may think of it as because we have supplied enough heat to this liquid. So the liquid is kind of saturated of this energy. But this word actually comes from a historical mistake, thinking that heat is a kind of fluid, but it is not. Okay. So however, we still use this name. Okay. So you just think that it's kind of saturated by heat and it starts to vaporize. If you provide further heat to this water, then what happens? Some of the liquid water will start to change to vapor. Okay, and in an equilibrium phase, you will see that both liquid and the vapor phase would coexist in equilibrium. And we will give a name to this state. We call it to be a saturated liquid vapor mixture. Okay, that means it is a mixture of saturated liquid and saturated vapor. Okay. And if you further supply heat, then all of the liquid water would change to vapor. And if the water vapor is still at 100 degrees C, then this vapor, we call it to be a saturated vapor. That is a vapor that is about to condense. Okay? If you just take away a little bit of heat from this saturated vapor, then some saturated liquid water will appear. So we will say that it's a saturated vapor. Okay, and if you supply more heat to this saturated vapor, then it will become superheated. Okay, superheated. Super means more. So this superheated vapor is that you give an amount of heat that heat up the vapor. Okay, so this vapor is not about to condense. Okay, if you just take away a little bit of heat from this vapor, then it would not condense immediately. Okay, for example, the water vapor at 1 atm and greater than 100 degrees C. For example, at the 300 degrees C, that will be the situation. Okay, so after talking about this terminology, actually those phases can be stated by using a diagram. Okay, so here, this is the TV diagram. Okay, you can see we have marked 1, 2, 3, 4, 5. This number just talk about the phase of the process. Okay, if you look at those figures very carefully, then you will see we have actually marked stage 1, 2, 3, 4, 5 to them. And here you can see that at stage 1, because it's lower than 100 degrees C, so it's a compressed liquid. And if you provide more heat, then it will go to stage 2, and we will have saturated liquid. Okay, further heating would make some of the saturated liquid to become saturated vapor. So we'll have a saturated mixture. Okay, for example, I have heated it to stage 3. From this line, you can see that there should be more saturated vapor than saturated liquid inside this saturated mixture, because this point is more deviated to the superheated vapor line. Okay, and I will talk about the portion in the later section. Okay, how can we determine the portion of saturated vapor and the saturated liquid? Stage 4, it is a saturated vapor. Okay, that is, we have changed all of the saturated liquid to vapor phase. And if you further heat it under constant pressure, then we would get a superheated vapor, and we go to stage 5. Okay, and look at one thing. If this heating under the constant pressure is replaced by the isobaric cooling process, or the water vapor having the same pressure, okay, the path will be exactly reversed. That means we go from stage 5. Suppose we take out heat from stage 5 at the same pressure, then it would trace exactly the same path and go back to stage 1. Okay? And the heat released in the cooling process will be the same as that added during the heating process. Okay? This is reasonable because all of the states we have passed through are equilibrium states. So we can exactly reverse the whole process and get from stage 5 to stage 1. So we also get one observation from our daily experience that the boiling temperature depends on pressure. That means it's not necessary to be 100 degrees C. Okay? We can see that this pressure and the boiling temperature are actually dependent. If the pressure is fixed, then the boiling temperature will be also fixed. Okay? For example, if we are having 1 atm, then the boiling temperature of water will be 100 degrees C. It would not be other temperature if other factors changes. As long as the value of this pressure doesn't change, then this boiling temperature would not change. Okay? And we will also give this kind of temperature a name called a saturated temperature. That means the temperature at which a pure substance changes its phase at a given pressure. And for the saturation pressure, we will use a symbol like this. Okay? Here you can see that we have a subscript, SAT. SAT just means saturation. And saturation pressure means the pressure at which a pure substance changes phase at a given temperature. Okay? Note that you must specify the pressure when you talk about the boiling temperature, because if you just change this pressure, then the boiling temperature would be different. And also, if you would like to talk about the saturation pressure, please also give the saturation temperature. Otherwise, the number would not be valid. Okay?